All right, guys. So sine of A over A equals sine of B over B equals sine of C over C. Now, I've had issues with people in the past saying, well, I didn't know what to do because my triangle didn't have A, B, and C in it. It had X, Y, and Z or M, N, and R, okay? What they're talking about is regardless of what your letters are, you take the sine of that angle and you divide it by the side that's opposite, okay? You then take the sine of that angle and you divide it by what is opposite. And then you can, if you need to, take the sine of that angle and divide it by what's opposite. Does that make sense? And that's going to generate these three ratios, okay? These three ratios are, I'm going to show you the best way I think you can check your answers to see that you got the right distances, or eventually when we talk about angles and finding angles in this, with this process, you can use this relationship to see if those angles are correct. So I want to just jump in and I want to do a handful of questions, and then if we have time, just set you free on your homework. So the first one here, all you got to do is draw that triangle. You don't need to write all the verbiage down and all that kind of stuff. Just draw the triangle.
So we can follow. What she's saying is you should print the notes off now.
My notes are on my website.
What is this? What did you just drink? Is my question. Because you're looking in there like, what is this?
Pop. Mountain Dew.
Are you
I didn't know what was, like, there's a weird glare in there. I thought there was something in there.
Makes sense. I thought that was harder.
Okay, so what we're getting at here at the law of sine, so this is a non-right triangle, correct? Non-right triangle. So our goal is to solve for segment A and segment C. Okay? So I'm going to write, every time that I do these, I think this is a benefit for you as well, to write down the three ratios that exist from the law of sine. So it is sine of A over A is equal to sine of B over B is equal to sine of C over C. Now, for our particular problem, we should be able to fill those in, right? Okay, so if I look at A for us is 48 degrees, right? Now, what is opposite A? Yeah, lowercase a, right? So that's an unknown value, so it stays a variable. The next one is going to be sine of B. Well, sine of B, what is our B in this case? 93. And what is opposite 93? 15. Is then equal to sine of C. Okay? Now, do we know C? What is C? Okay, so 180 minus 93 minus 48, which would be 39 degrees. Okay? Now, what is opposite C? Lowercase c, right? All right, so now I just did them a different color so I can talk about them, but the red one paired up with the black one as a proportion would have how many variables in it? 2. It would have A and C in it, right? Will that allow me to solve for A or C? No. So what I like to do is always like to figure out the proportion, the set of ratios that will not give me information back. And then that tells me automatically the next 2, the other 2, will give me information back. So can I take the first red one and the blue one and set those equal each other and solve that proportion? Sine of 48 over A equals sine of 93 over 15. Can we solve that for A? How do I solve a proportion? Cross multiply. So it's going to give me A times sine of 93 is equal to 15 times sine of 48, right? What do I then need to do to solve for A? Good. Divide both sides by sine of 93, and it's going to give you 15 sine of 48 all over sine of 93. That there then will end up being your answer for how long distance A is. Okay, I want to grab a calculator to see what that is. When you do these things in upcoming courses, a lot of times the upcoming courses say, leave it that way. Because it's less work, right? If I leave it that way, I'm done. If I've got to go in this class to type it in 2 decimal places, 3 decimal places, 4 decimal places, I got to grab my calculator, type that in, right? Okay? So later on, they're actually trying to, the way they word questions, they're trying to get you to do a little bit less work. The next thing I want to do, so that's solving for A. Okay? Once I find that, and I'm just going to tell you that it's approximately 11.16. We're going to go back and talk about this in a moment, and I'll evaluate that on the calculator. But it is 11.16. Now, looking at trying to solve for distance C here, I have to use this. Everybody agree I have to use that ratio to solve for C? It's the one that involves C, right? But now, because I've already found the 11.16, I have a choice of whether I use the red ratio or the middle one, the middle blue one, right? Which one, and it doesn't matter because both are going to give you the right answer, but which one's going to be the best, Ty?
The middle.
The middle one. Why?
Because it's full numbers.
Right. Okay, so the 11.16, I've rounded that, right? Okay. So be careful, and somebody earlier today, like I presented, okay, what if the question started off with like a 15.2? Because that's not a whole number, but because the question started off with that, I know it's not rounded, right? Okay? We should know that the 11.16 is the one that we want to stay away from because it's rounded. Not necessarily 100% because it's just a decimal, but because it's a rounded decimal. Does that make sense to everybody? Okay? And we don't want to bring into the picture a rounded value that could compromise my tenths place, hundredths place, thousandths place, depending on how the answer or the question is structured for my answer. If you are going to use the 11.16, that's fine. But if your answer says round to the hundredths place, then I better use that 11.16 out to more decimal places than just 2. Okay? I should probably go out 4 or 5 to guarantee myself safety in regards to not altering the hundredths place in my answer. Does everybody understand that rounding error kind of being compounded and compromising our final answers depending on what the units are, or the decimal place they asked for? Okay? So Ty is right. If I can avoid it, I'm going to avoid it 100%. So I'm going to put those two together. And I have sine of 93 over 15 equals sine of 39 over C. I'm going to solve that. Cross multiply, so I get 15 sine of 39 equals C times sine of 93, right? How do I solve for C? Good. So you get 15 sine of 39 divided by sine 93, and that's going to allow me to solve for C. Okay? I just want to kind of draw your attention to this because I don't know if you guys are aware of this. When you are using Desmos and you got a lot of stuff like drawn in here or typed in here, so let's say I got all this stuff in here. and I don't want to delete every one of those individually, I can come up to the gear up here, hit edit list, and delete all, right? Let's look at my mode right now real quick. I'm in degrees, right? Okay. I'm going to go up here, and I'm going to delete all. And now go back to my settings. Look what it put me into. Put into radians, okay? So that delete all for the calculator on Desmos is simply like a refresh, which is going to get the calculator just to be reset back to its factory settings, essentially, okay? I don't know how that calculator on your end-of-course exam is going to be developed like that, okay? It might have this capability, okay? Essentially what your calculator on an end-of-course exam is you don't have this graph, but you've got like this keyboard in front of you in one of these boxes, okay? I think I've shown you in the beginning of the year what that calculator is supposed to look like, but I'm not sure about the functionality of it in regards to deleting and resetting and that kind of stuff. So just be cautious of those things. All right, so let's type these answers in. We have 15 sine of 48 over 93. 15 sine of 48 divided by sine of 93. Okay, and that's not right because I need to be in degrees. So 11.16, and that was the number I told you were going to get, right? Okay. If I do the other one, 15 sine of 39 divided by sine of 93, and that's C. So we've got our two values. We've got the length of A, and we've got the length of C. We also know angle C to be 39 degrees, so we solved that triangle, right? We found all 6 parts of that triangle. Okay. Now, I'm cautious of this because I want to make sure that we've done things right. Okay. So what I'm going to do is I'm going to try to see, because we should know this, the sine of A divided by A should equal the sine of B divided by B, which should equal the sine of C divided by C. We agree with that? That should be the case. That's what the law of sine says. Well, if I take A is 48, right? Sine of 48, which is that number right there. If you divide that number by the length of the side opposite 48, which was A, right? Which was the 11.16 number. I'll capture that number, and we'll divide them out. And I get that ratio. So that number right there is what that highlighted ratio is. Does that make sense? For this particular problem. Let's see if that's the same as that ratio. So I'm going to take the sine of B, which is 93, and we'll divide that by its side opposite, which is 15. What do you recognize about these two numbers? They're the same. Okay? I don't know why this one shows one more decimal place than what this one does. That's why you're seeing, maybe if you look at the end, that 8 and that 7. Okay? I guess this that 6 is the same decimal place as that 7. But then if I go to the sine of, the other angle was 39, and divide it by C, which was the side opposite 39, so grab that number, paste it in, does that give me the exact same ratio? So, and those ratios just written as decimals, but we see that those ratios are all equivalent, which means that we've met the law of sine. Does that make sense? Which means we found the correct distances. Okay, and that's the way you can quickly check to see if you've done this stuff correctly and found the right angles and found the right distances. Is that all right? Okay. My hopes are, and it's kind of the consensus from the previous 3 classes, is that this is structurally, it's the same question over and over and over again, obviously just using different values. And then once you set up the proportion, solving the proportions is always the same algebra, right? So if we're going to learn that idea, that concept, we should be able to run through as many of these as we possibly can. Okay? So I want you guys to do this one. It says find AC, which I do want you to do, but I'm just going to put lowercase b here. So find B. and also find A. So take a couple minutes, see what you come up with. We'll come back together, reconvene, and see if your answers match up to mine.
How we do this?
Shut up. How we do this? Yes. Go 2 decimal places. It's fine. I am 100% sure. Shore is on.
Sure.
Yeah, shore is on the ocean. Yes.
I did it. I did it.
All right, so we're looking at, if we write the 3 ratios, you should have sine of one of the angles. So let's say 22. What'd you put under sine of 22? B. Okay. The next one should be sine of, okay, so you put, what'd you put here though? 40. And what'd you put on the bottom? 24. Okay. So this angle here, they're going to hide that one all the time. They're not going to give you all 3 angles. And if they do, that should be a rare occasion. And then sine of 118 over A, right? Okay. Now, because this one's purely numerical, That's the one that you're going to want to use with the one that incorporates B, and that'll help you solve B, right? And that's the one you're going to want to use with A to help you solve for A. So when you come up with these two, you have sine of 22 over B equals sine of 40 over 24, right? So it's the exact same steps as the last question. I'm going to multiply my means, it's going to be B sine of 40, and we'll multiply my extreme. So I get 24 sine of 22. Now I'm going to divide both sides by what? Sine of 40. Remember, sine of 40 is just a coefficient, right? That's just another number. It's a decimal. But sine of 40 is a better version of it. So divide both sides by that. And that should give me my B value. Okay? Do the same thing then with these two to solve for A. So I'll say sine of 40 over 24 is equal to sine of 118 over A. Cross multiply A sine of 40 is equal to 24 sine of 118. Again, just like up here in the blue one, this sine of 40 is a coefficient. So divide by it to both sides, and you'll be left with 24 sine of 118 over sine of 40. What did you guys come up with? If you got those, what were the values for B? 13.99 and A? Okay, those numbers sound accurate from what we found today in previous classes. Okay, is that pretty straightforward how we do that? Yeah. Okay, now there is another triangle that you can use this stuff, and so the information that they present us with in both these examples was angle, angle, side, right? You knew two angles and a side that was either excluded. Okay, that was the first one. This one is angle, side, angle, right? Does that make sense? So I know two angles and the included side. With those two formattings of information, you can use the law of sines, okay? And you can be guaranteed that there's one and only one answer, okay? So this one you see that's angle, angle, and then the side was on the outside, right? It was not included between those two angles. There is a situation, but it takes about a day and a half, 2 days to fully understand and discuss. So we might end up having to put this one on the back burner eventually. But when you're given this information, you see how you're only given one angle and then two sides. Well, if I set up a proportion here, what I'm going to end up with, and we haven't done this in the other class, so I'm not going to go too far with this. If I go sine of 120, what should that be over? 18. Now look at your picture. What other number do you have to use out of that picture? 11, right? And 11's a distance, so it's one of your denominators. So right here should be sine of S. Okay? So there in that proportion you'd be solving for an angle, right? If you get into a situation where you're solving for an angle, what happens with the law of sines? What happens is that there might be absolutely zero triangles that exist with that information. And I'll show you a picture of this at some point, but that information, that criteria, might not allow all three segments to intersect and touch at endpoints. Does that make sense? Okay. Or it might provide just one triangle where that does happen, where they all do intersect, the segments all intersect at each other's endpoints. Or you might get a situation where you get information that provides you two different triangles that could be created. And we call that the ambiguous case, and it's a pain in the butt. And that's why yesterday I wrote on the board that it was the ASS orientation, right? Because that helps you remember that it's a pain in the butt question, and you've got to do a lot more work. It's about 2 to 3 times more work to solve that type of problem with law of sines than when they give you angle, angle, side, or angle, side, angle. Okay? I'm not too concerned right now about us solving ones like that because I would argue that that's not going to be a question that's presented on the end of course exam. But here's something that I want you to think about. if I were to give you this triangle here, and this would be the last thing we talk about, the right triangle, let's say this is, I don't know, 55 degrees. Let's say this is X, and let's say this is 30. I'm going to do the exact same triangle over here. We're going to solve these using two different approaches. Because we're in the law of sines, let's approach this one using law of sines. So what angle do you know? What two angles do you know here? Yeah, 55 and 90, right? So across from 55 is your X, and across from 90 is your 30, right? So I can cross multiply, I get X times sine of 90 is equal to 30 sine of 55. Does that work? How do I solve for X? Just like the last examples, we divide by sine of 90, right? So it'd be 30 sine of 55 divided by sine of 90. Okay, so we get an answer. Don't worry about typing down your calculator yet. Let's come over to this one. It's a right triangle, so shouldn't that exist? What side is X? Opposite of side 30. Hypotenuse. So can I say sine of 55 is equal to X over 30? And then instantly have 30 sine of 55 equals X? Was that quicker over here? Okay, but here's the thing. That looks different than that, doesn't it? Why are they the same thing? Okay? Good, okay. So, that one right there and that sine of 90 are the same value, okay? If you type on your calculator sine of 90, it gives you back 1. It's a concept we'll talk about in trig and why it's 90, okay? Has to do with circles. Okay, y sine of 90 is 1. But my hope is that in seeing this, you recognize, okay, law of sines works with the right triangles. It gave me the same answer. But if I'm not paying attention to the tools that I'm able to use to do a job, I might do a job and it might take me twice as long than necessary. Does that make sense? Okay, you know, if I've got a hammer and I've got a nail gun, which one should I probably use if I'm framing a house or something like that? Probably use the nail gun, right? It's going to be more efficient, okay? If I've got SOHCAHTOA or law of sines at my disposal and I've got a right triangle, I'm going to use SOHCAHTOA. It's quicker, okay? So that's kind of an approach that I think that's the mathematics part, okay? All the other stuff is just calculations and algebra and stuff like that, but arithmetic, the math part is the logical thinking about what tool to use in what situation. Okay, there is, and I want you guys to start working on it, there is an assignment 8.5, okay, that is open. There's 7 questions on it, due on Monday. I've also, at the request of some of you, opened up the optional review already, which will be due on Thursday because that's when our test is. And those of you that need that worksheet opened up still, I will do that right now. Huh? So here's the thing. I want you to stay seated until the bell rings. I want us working